Hi, in this video, I'm going to be showing you my implementation for graphs and graph traversal. This exercise requires us to make use of these two graphs to show our algorithm, but we need to make use of an adjacency matrix to show the relationships of the vertices. In this program, I'm used array to represent both the vertex list and the adjacency matrix. So in here, since both graphs are actually unweighted and directed, I'm going to be using Boolean values to represent their relationship. So in the program, the way to store this is actually like this. So the vertices will be stored in a one-dimensional array, while the values for the adjacency matrix will be stored in a jagged array. Okay, the difference between the depth first and the breadth first search is supporting data structures. So depth first search makes use of a stack to store the visited vertices, while a breadth first search makes use of a queue. Okay, so now I'm just going to run through the algorithm for the traversal very quick. Okay, so for the depth first search, so the first step is you set your first vertex to visit on, and then every time you visit a vertex in a depth first search traversal, is you actually put it on top of the stack. So you push it on top of the stack, and then you set the cursor, the vertex position or the vertex cursor to that vertex where you actually visit. And then after you set that vertex position, mark it as visited, then from there you look for any possible path. So once you get at least one, then you push it into the stack, and then you repeat the same step. So now, if in case you don't get any matches for any possible path, then that's where you actually go back into your stack and pop those values. So it will look like actually that you're actually going back to your path. So since the one on top is the one on top is the one that you previously visited, then in effect you're just going to be finishing the stack as you go back. So once you've visited or you found a vertex that has a possible path, then from there you can continue on and move into a different direction. Then so for breadth first search is a bit different because this time is using a queue. So as you start to visit a vertex, you then put it into the queue, and then you set that as your first vertex position. So from that position, what you do is you look for all possible paths, but as you move along, you actually don't move the vertex position yet. So what you do is you just mark all the possible paths as visited, and once you've completed all those possible paths, mark it as visited, then that's the only time you actually go back and change the vertex position. So as you go and move to a vertex position, then also you update your queue. So in here, you see that every possible path that is visited, the queue is already updated, right? Then, so it will mean that from the first vertex, you have two possible paths, then your queue already has two values. And then as you move your vertex position, then that's the only time you start to the queue. And then as the queue, from there you start to look for other possible paths until you've emptied your queue. Okay, yeah. So that's for the breadth first search. So for the demo, just very quickly, since we don't have much time, so I'll just perform a depth first search for the first one, and breadth first search, depth first search for the second one, and then maybe just simple traversal breadth first search to the second graph. So yeah, you see here the order of the output is like this for depth first search, and this one for the breadth first search. Yep. So thank you.